word is statistic without the letter S, and that word is different from the statistics. So this statistics is a subject or a science. That word will be statistic. And that will be completely different from this statistics. So keep this in mind for later chapters like chapters 8, 9, and 10. Yesterday, we defined the subject statistics as a science of making decisions under uncertainty, under unpredictability, based on numbers, based on data. We divided the subject into two parts. We said the first part is to describe the data, and the second part is to make decisions based on the description. And in between, there is a bridging concept of descriptive to inferential. That bridging concept, that concept that bridges the descriptive statistic to inferential statistic, that concept is a key concept of statistics, which is probability. So we started probability chapter and we were going through some of the terminologies from probability. We did not start probability formally. We were going through the terminologies of the chapter. And the first terminology we went through was the random experiment. And as I said in the last class, whenever you encounter a problem of probability, there will be a random experiment in the background, there will be a sample space in the background, and there will be an event in the background. If you are able to identify these three things, what is the random experiment, what is the sample space, and what is the event, the probability question becomes very, very easy. So the definition of random experiment is what? It's a procedure, it's a method that if you do it, you get some outcomes in terms of numbers. And the word random means the outcome is unpredictable. And unpredictable in itself contains the definition that it should have more than one outcomes. If there is only one outcome, it cannot be unpredictable. So these are some of the properties of random experiment, that it has unpredictable outcomes, obviously more than one possible outcomes, and the outcomes are unpredictable. In terms of numbers, of course, in this course you will be more interested in numbers. Sometimes not in terms of numbers, but ultimately you are going to convert them into numbers. An example we gave was to pick a student randomly from KFUPM and ask him about his current CGPA. So the answer to that one, that's a random experiment. Then we went through the definition of a sample space. We said if you define the random experiment, and after defining the random experiment, you get to know what are the possible outcomes of this random experiment, and you write down those possible outcomes in terms of a set. That set is called sample space. So a simple definition of sample space is a set of all possible outcomes of random experiment. It can be a set of continuous numbers, it can be a set of yes or no, it can be a set of 3, 4 numbers, it can be a set of infinite numbers. Finally, we defined event. And we defined event as any desirable part of the sample space, subset of the sample space where we are interested. So this is going to be the question. Whenever you see the question, the required probability will be for a specific event. So when I say desirable, that means this will be the interest of the question. And we find the probabilities of these events. we find the probabilities of these events. So now I would like to take any questions at this point, now that we have taken a review of what we did in the previous class. If there is any question, I would like to take it at this point.
Doctor,
Yes,
when you specify a date, is that a part of the event?
we specify the
date.
The date is not a random variable. The date is variable, but not a random variable. Because if I tell you that today is 7th of June, tomorrow the date will change. It is an experiment and it will change, but it will not change unpredictably. You know, tomorrow will be 8th of June.
Correct, yeah.
So as long as the experiment is not random, there is no concept of probability. Probability is the measure of uncertainty. So if there is no uncertainty, there is no probability. So finally, the bottom line is that the probability, which we stated right at the start, is a measure of this uncertainty, and we find the probabilities of these events. And by definition, the probability of an event A, for example, is given as it is denoted by P of A and is given as number of outcomes in A divided by the number of outcomes in your space. Number of elements of set A divided by the number of elements of set S, the sample space. This P of A is a number between 0 and 1, where 0 indicates what? 0 indicates that the corresponding event is impossible, and 1 indicates what? A sure event. These are two extreme values of P of A. These are two extremes of P of A where you will find no uncertainty. Picking a student from this class, what is the probability that the student will be male? 1. Sure event. What is the probability that the student will be female? 0. Impossible event. Let us have a simple example of probability from where we will move on. Suppose there is a box of manufactured products which contains 5 electrical instruments. Of which 3 are working and 2 are defective. This is the scenario. If an object is selected randomly find the probability that it is defective. Now look at the question. The question says, look at the whole statement. From this statement, I will tell you what is the random experiment, what is the sample space, what is the event, and how do we find the probability of this event. So the experiment is you have a box. You have a box of 5 items, 5 instruments. And the organization of the box is that there are 5 working instruments and 2 defective instruments. And the experiment is to pick one instrument out of those 5. That's the random experiment. The experiment is to pick an instrument from the box and see if it is defective or not, if it is working or defective. What is your sample space? Sample space is a set of all possible outcomes of your random experiment. So in a sense, your sample space is working working, defective, and defective. So in a sense, in your sample space, there are total 5 instruments, out of which there are 3 working and 2 defectives. That is the organization of your sample space. And if you look at the sample space, we defined something which is n of s. And we said these are the number of elements of your sample space. We can define this number here now. Your n of s is 5. There are 5 elements in your sample space. So we defined the experiment, although in question we don't need to, but we know what is the background experiment. The experiment is to pick an instrument from the box and see if it is working or not. We don't need to define n of s, but it will help you finding the probability. We know this is your sample space, so the number of elements in your sample space is 5. That is your n of s. Now we need to know where is the interest of the question. The question says find the probability of what? The probability of a defective instrument. So event, let's call it A or B or whatever. The event A is that the instrument is defective. So your set A will be D1, D2. These elements will belong to your set. This is where the interest of the question lies. You can also define the number of elements in A, which will be 2. Now that you have everything, you can simply plug in the numbers into the definition of P of A, which is n of A divided by n of S. So now you're ready to get the answer. That is, the probability of A, which is n of A divided by n of S, is 2 over 5, which is 40%. Similarly, I can ask you to find the probability that the item is working. You define an event B as the instrument is working. You already have the sample space for this question. So your n of B, basically your set B will be W1, W2, W3. So n of B is 3. And finally, your probability of event B will be n of B divided by n of S, which is 3 over 5, which is 60%. I can also ask you the question indirectly. Instead of asking to find the probability that it is working, I can ask you to find the probability that it is not working. Luckily for this question, the only other category is defective. So this is going to be equal to 40%, but this is not going to be the case in every question. You can have more than 2 categories. So in that case, you need a general solution for the probability that it is not working. This is called the complement of an event, the opposite of an event. This is called complement. This is the complement of event B. And the notation for complement in probability, it is B bar. We call it complement. And the formula for finding the probability of complement of an event is the simple formula, which says that probability of the complement of an event is 1 minus probability of original event. So we can find it from probability of B, that will be 1 minus 0.6. This is 0.4, which is actually what? This is the probability of defective. Why it became the probability of defective? Because the only category other than working was defective. So it came out to be the probability of defective. But this will not be the general case. If you have 3 categories, 4 categories, this will not be the general case. So these are 3 basic problems from where we can initiate the concept of probability with a very simple example of box of 5 items, 5 instruments. Okay, before I move further for some complex problems, if anyone has any question from these 3 simple problems, you may go ahead now. Ryan Ibrahim.
Doctor?
Yes.
In the complement, if we have 3 statements like working and broken and half broken, is it will be the same?
If there are 3 categories, working, broken, and half broken, the general formula will be the same. This formula will be the same. You are trying to find the let's do that. Let's do that. This is a nice question. Faris. Walaikum assalam wa rahmatullah. Yes, Ahmed.
Yes, it's me. Thank you. Since more than half an hour, I was looking for your email and sending email, but now I saw it through syllabus. Okay.
Okay, Faris, please go ahead with your question.
Yeah, Doctor, I will ask after you finish.
Okay, let me state the question. That the categories now we have, let us say, a total of 10 instruments in the box, and as Ryan defined, there is like 6 working and 2 half broken and 2 fully broken. Let us say this is the organization of your space. I can also write the space in this way. working 1, working 2, working 3, working 4, working 5, working 6, half broken 1, half broken 2, fully broken 1, and fully broken 2. Let us say this is the organization of my space, and we try to find the probability. Find the probability of picking a half broken instrument. So let us define this as event C, that the instrument is half broken. So your set C will be H1 and H2. Your N of C will be 2. Your N of S will be 10. So the probability of C will be 2 over 10, which is 0.1. Now, the next question is the complement. For example, I say that find the probability of picking not a half broken instrument. So that will be simply probability of C complement that is required in this question. So you will use the complement rule, 1 minus probability of C, which will be 1 minus 0.1. This is going to be 0.9. The only point I was saying that this 0.9 is not going to be equal to probability of W or probability of B. Like in the first question, this 0.4 came out to be exactly the probability of A.
It will be a mixture.
Because the only other category was A. Now the only other category is not W or B, so it will be different from these things. But the general rule will be same. Yes, Faris.
I think 0.2, not 1.
0.2 or 0.1? Ah, thank you. 0.2. 0.2. Yes, thank you. Yes, Faris, now go ahead with your question.
Yes, please, could you go up?
More?
Yes, more than this. Between 0 and 1, the statement. Yes. So it is it possible to be 0 or 1, or between each between 0 and 1?
It will be between 0 and 1. It can be 0, it can be 1, and 0 or 1 means that you are talking about an impossible or a sure event.
Yes, clear. Thank you.
Muhannad.
Yes, Doctor. What if the event have a combination between two things? For example, 4 working and 1 half working.
Now we are talking about more than one events, more than one pickings, right?
In the same picking.
In the same experiment, now we're talking about, let's say you pick 3 items and 2 of them are working, 1 of them is half broken. Is this your question?
Yes, I mean the event will be the combination, not only one.
If I understood it correctly, your question is that you have a box of 10 instruments, 6 are working, 2 are half broken, 2 are broken. You pick like 3 or 4 instruments from the box, not one, but more than one. And yes, you say some of them are working, some of them are half working, some of them are broken. Is this your question?
Yes.
Yes. So we will go to this case. This is a complicated case than this one where we are picking more than one objects. So the next topic will be picking more than one objects. Here we stuck to the case where we pick only one object. So when you pick only one object, the counting is very easy. You just count that you have 10 elements in the sample space. You just count that you have 6 of them working, 2 of them half broken, and 2 of them are broken. But if you are picking more than one object from the space, the counting is not very easy. And I will show you why it is not easy. And then I will show you the easier way of counting, which is, as Muhammad said, it's something like combinations. So we'll talk about those combinations later, inshallah.
Doctor,
Yes.
if I want to find the probability of W, can I say B 1 minus B of H plus B of B?
1 minus all other categories, that's the longer way. Yes, you can say, but the direct way is 6 over 10.
Okay.
Any other question?
Doctor?
Yes.
And the final case that my friend suggested, when we found the complementary, this percent is a mix of all other probabilities, right?
Exactly. This is actually the sum of all other probabilities other than C.
Yeah, now I see. Okay.
In general, probability of C complement is basically the sum of all other probabilities than C. All the other than C's. Now, there was one question which said that if you pick more than one objects, what will happen? If you pick more than one instruments, what will happen? As long as you are selecting only one instrument, the counting is very simple. How many elements are favoring your event? You simply count them. H1, H2, that's it. How many are there in the sample space? You simply count them. There are 10 of them. There are only 10 possibilities here. If I'm picking a single instrument out of this space, there are only 10 possibilities. I can pick W1, I can pick W2, W3, W4, W5, W6, H1, H2, B1 or B2. Very simple counting. But if I pick 2 or 3 or 4 or anything more than 1, the counting of possible outcomes is not very easy. Let me give you an example of this. Let's go back to our small example of only 2 categories, where we had a total of 5 instruments. 3 of them were working and 2 of them were defective. And I pick 2 instruments instead of 1. Now, what are the possible outcomes? What will be my sample space? My sample space is not going to be W1, W2, W3, D1, D2, because now I'm going to pick 2 of them. So now I got a number of possibilities, and those possibilities depend upon many things. I can have both working, I can have both defective, I can have one working and one defective. I can have first working and second defective, or second working and first defective. So I can have a number of possibilities here. Now those possibilities, they depend upon how you are picking. And we did not face this question in one picking, because it doesn't make sense in one picking. In 2 pickings, the first thing you need to know is, when you pick the first item, do you put it back before picking the second item, or you don't put it back? That's the first question you have to answer. This is the first question that will be there somewhere in the statement of the question. This is called with replacement picking and without replacement picking. So you have to see first are the pickings with replacement or is it without replacement? With replacement means you pick one instrument and before you pick the second instrument, you put it back in the space. So the size of your space is still 5 in with replacement. But without replacement, when you pick one, you keep it in hand. Now the size of your space has reduced. It's 4 now. Before picking the second item, you have only 4 items left in the box. So these are some of the questions you need to answer. Now let me write the things formally. In general, you will be selecting R objects out of N. The first question you need to answer is, are you selecting with replacement or not? If it is with replacement, there is a different method of counting. If it is without replacement, you have to answer another question. For example, it is without replacement. Now the next question is, does the order matter to you or not? For example, you are picking 2 items out of those 5 and there is first white and second one is the first one is working and the second one is defective. Does this matter to you that the first one is working and second one is defective, or it's just that you want how many are defective and how many are working? So further, in without replacement, you have to make sure, is the order important or not? So whenever you are picking more than one objects, you will face these 3 situations. There is a fourth one, obviously, but I will not discuss this one. That does not belong to this course. So these are the 3 situations you will face. Picking with replacement, picking without replacement where order is important, and picking without replacement where order is not important. So let us discuss all these 3 cases in detail for your example. So for your example, you have a box of 5 instruments. 3 are working, 2 are defective, and let us say you want to pick 2. And let us say you want to pick 2 with replacement. When you pick 2 with replacement, what are the possible outcomes? Let's try to make a sample space. You're trying to pick 2 now. Let us see what your sample space is. Is it possible that both of them are W1? You pick W1, you put it back, and W1 comes out again. Is this a possible outcome?
Yes.
Yes, it's possible because you are picking with replacement. It's possible that you get W1 working the first working item, you plug it back inside and then you get it again. This is a possibility. Another possibility is you get W1 in the first picking and W2 in the second one. This is another possibility. You may get W1, W3. You may get W1, D1, or you may get W1, D2. These are the 5 possibilities with W1 as the first picking. You may get W2 in the first picking. You may get W2 and W2 again. You may get W2 and W3. You may get W2, D1, or W2, D2. These are 5 more possible outcomes of your experiment. You may get W3 in the first picking and W1 in the second. W3 in the first, W2 in the second, W3 in the first, and W3 in the second. You may get D1, W1, D1, W2, D1, W3, D1, D1, and D1, D2. You may get D2, W1, D2, W2, D2, W3, D2, D1, and D2, D2. This is already looking boring. And of course it is looking boring. But anyhow, this is your sample space. If you have that organization where you have 5 instruments in the box, 3 of them are working, 2 of them are defective, and you pick 2 with replacement, this is your sample space. How many elements are there in your sample space?
25.
25. So now you can write that your N of S is 25, not 5. And that W1, W2, W3, D1, D2, that is not your sample space. This is your sample space, an extended sample space. Now from here, if I ask you the question, find the probability that both of them are defective, you will write your event and you will see your event has these 4 outcomes. Both of them are defective, and your answer will be 4/25, but I will get to that one later. Before that, I will discuss all the 3 cases and I will try to make the sample space for all 3 cases. Now, any question from the case where I tried to make the sample space for with replacement case? And of course, this is boring, this is long, and in exam, I'm not going to ask you to make the sample space because we have an easier way of getting this number 25. Ultimately, what is your objective? Ultimately, your objective is to find the probability, right? And for probability, you need what? Let me zoom out. For probability, you need, where is the definition? For probability, you need these 2 numbers in the green and in yellow. You don't need to see the organization of your sample space. You need n of sample space. So if there is a direct method that can give you this final answer n of s, you don't need to see the sample space. If there is a direct method that gives you n of a, you don't need to make the sample space. So manually, I'm trying to make the sample space just to show you that this is a long and boring procedure. And we really need some smart techniques that give you this number directly, 25. So ultimately, the objective is to get to this number 25, and we will define those techniques, and we will define that how we get to this number 25. Before that, I'm moving to the second case, and the second case is where I'm picking now without replacement. I don't replace the object back to the box before picking the second one, but now the order is important to me. Whether I'm picking the first working one or the second working one, that's important to me. So I'll copy this whole thing and I'll paste it here. And now we discuss it. OK, now in the second case, when you are picking without replacement, is it possible to get W1 and then W1 again?
No.
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 It's not possible. It's not possible. This is no longer an element of your space. Is it possible to get W2 and then W2 again?
No.
No.
No. So this is also not an element of your sample space. Similarly, W3 is no longer an element of your sample space. D1 cannot happen. D2 cannot happen.
Doctor, I don't
Yes.
understand this point.
Sorry?
I don't understand this point.
OK, I'll explain it again. OK, in the previous question, what we were doing was we were picking 2 objects out of 5, and we said we are picking with replacement. And what does the can you raise your hand? Who was it who did not understand? OK, Muhammad Faris. Now, in the previous question, we were saying that we are picking with replacement. That means you pick one item, and before picking the second item, you replace it back. That means in the second picking, you can get the same item again. W1 means in the first picking, you get the first working item. And in the second picking, you get the same item again because you replaced it back. You put it back in the space before picking second. So that was a possibility. Now here, where we're discussing without replacement now you are picking one object from the box, and before you pick the second, you are not putting the first one back. That first one is still in your hand. So when the first one is in your hand and you pick the first working one, is it possible to get the first working one again from the box? No, it's not there in the box anymore. It's in your hand.
Yes, clear, Doctor. Thank you.
Similarly, if you pick the second white one in the first picking, now it's in your hand. Now you cannot get it again. So the diagonal elements, 5 diagonal elements where we got the same item 2 times, that is no longer a possibility now.
Clear. Thank you, Doctor.
So we get rid of the diagonal. It's not there anymore. That's not a possibility anymore. And the number of elements in your sample space are not 25 now. They are 20 now. And again, I would like to reiterate, you need only this. You need only this to solve the question of probability. You don't need to make this whole sample space. We will never ask you to make this sample space. We will ask you to give us the probability of the event. And to give us the probability of event, you need the two numbers, the numerator, the denominator. We are talking about how to get the denominator. There is same method for getting the numerator. We'll talk about that. But before that, let's get to the third case. Before I get to the third case, I would like you to see what is the difference between this outcome and this outcome.
The order is different.
The order is different. The order is different. Why I wrote them 2 times in my sample space?
Because we care about
Because we care about the order.
Because we care about the order. For us, W1, W2 is different from W2, W1. So we wrote them separately. What if the order is not important? You will not care about this one, and W1, W2 or W2, W1 will be the same thing for you. So you will write it only one time. Similarly, let me highlight another one for you. W2, D1 and D1, W2. Same 2 items, but in a different order.
D1 and D2, D2, D1.
So
as you keep looking, yes,
10.
as you keep looking, you will notice that the upper triangle is a mirror image of the lower triangle. There is this upper triangle and there is this lower triangle. As you keep highlighting, you will get to know that the upper triangle is basically a mirror image of the lower triangle. You will see every element of the upper triangle is repeated in the lower triangle in a different order. And why we wrote it 2 times? I repeat, we wrote it 2 times because we care for the order. For us, the order was important. Now, in the third situation where you are picking obviously without replacement, but the order is not important. If the order is not important to you, then the sample space will be only one of these triangles, whatever you like, the upper one or the lower one. It doesn't matter because the order is not important to you. So now your sample space, let me copy whole this thing again. Oh, it's not allowing me to copy only the space. Copy. And let me paste it here again. And this time, not only the diagonal elements will be gone, but one of the triangles will also be gone. I'll get rid of the lower triangle. So now my sample space has only 10 elements. Exactly, 10 elements. And again, I'm not interested in those 10 elements. I'm interested in the number 10. I'm not interested in what are those 10 elements. Is it W1, W2, W1, W3, W1, D1? I don't care. I care about this number 10. I care about another number that will come in the numerator, n of a. Now I want you to think about a situation where I pick 3 items, not 2. What will happen? Let's go back to the first situation. When I picked 1, there were 5 outcomes. When I picked 2, there were 25 outcomes. If I pick 3, there will be 125 outcomes. If I pick 4, there will be 625 outcomes. Is it manually possible to make those 625 outcomes write down in exam? No. Of course, no. This is where we talk about some counting techniques. And those counting techniques, they give you this number 25 directly. You don't need to make the space manually. You can get this number directly from those counting techniques. And this is where those counting techniques come into your help. So we will talk about these smart counting techniques that give you this number n of s and also the numerator n of a without actually making the sample space. We'll talk about those counting techniques in the next class. This is where I stop. And this whole thing where I actually made the space manually, this is kind of useless thing. And I wasted all this time only to show you that manually it's very tough and it's very time taking to make these space. And later I will use the counting techniques and I will verify that even using the counting technique, you'll get the same number 25, you'll get the same number 20, you'll get the same number 10. So we will verify these answers from the counting techniques and we will solve the questions of probability. At this point, if you have any question, you may raise your hand, and if you don't have a question, you can leave the session now. Faris, please go ahead.
Yes, doctor. In this case, the sample space was extended because we pick each times one more item, right?
You're talking about 3 items or 4 items?
No, if we go up, we see like we have only 5 sample space.
Yes, if you go down 25 and if you pick another one, it will be 125 and so on. Yes, if you keep picking more items, there are more possibilities.
Yes. And I have another question, please. If we have sure event, can we always say we have one category?
Yes, for sure event, no, you'll not say one category. Maybe the event is a combination of all the categories. For example, here in the question, I ask you that there are 5 electrical objects in the box. You pick one object, give me the probability that it is an electrical object. So all of them are electrical objects. So I'm asking a question in a way that contains everything from the sample space.
Yes, clear now. Thank you, Doctor.
Welcome. Any other questions?